Hello my friends, today I want to do a video on exponential functions, and at the top of this worksheet I have the notes for exponential functions. Basically, if we look at this very first one, there is no number, no constant at the end, so that means the horizontal asymptote has to be y equals 0. So we're going to have an asymptote that runs through this line, which means a couple things. I know a few things from that. I know, first of all, that as far as the x-intercept is concerned, you will not have one, because if you cannot touch the line y equals 0, then you will not have an x-intercept. Okay, so the next thing we're going to look at, actually maybe perhaps I should pull these notes down here so we don't have to go quite so far away to see them. We'll set them right here on top. All right, there we go. Our notes tell us that the y-intercept is whatever number is here when this number right here is 0 and when this number is 0. So when x is 0, we're going to have 5. So we're going to plot 0, 5. 1, 2, 3, 4. So that gives us this point right there. If you don't want to trust that, that is absolutely fine. You don't have to trust that. You could do the math. The math would be f using 0 is equal to 5 to raise to the 0 power. So when x is 0, we have 5. 2 to the 0 power is 1. And so when x is 0, 5 times 1 is 5. That's how we get that. All right? If we wanted to do the same thing, this time using the number 1, if we wanted to use 1 instead of 0, we can. If we let the exponent be 1, then 2 to the first power is 2, and 5 times 2 is 10. So this would be the number 10. So we would have the ordered pair 1, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That would be right here. And then if we wanted to, we could do the exact same thing for when the value of x is 2. So when the value of x is 2, when the value of x is 2, that would mean we have 2 squared, which is 4, which would mean we'd have 20, which we can't really graph. So what if we went the other way? What if we said x is negative 1? So what if we allow x to be negative 1? So if we allow x to be negative 1, if we put negative 1 in here, then we're going to remember back to our Algebra 1, and our Algebra 1 said that if we had 2 to the negative first power, that's the same as 1 over 2 to the first power, which is 1/2. So 2 to the negative first power is the number 1/2, and 5 times the number 1/2 is 5 halves. So this would be 5 halves. So that's the point, negative 1, 5 halves, and negative 1, 5 halves is negative 1, 2.5, which would be right there. And then if we said, you know what, let's do it again, but this time let's let the power of x be negative 2 instead of negative 1. And so if we let the value of x be negative 2, that means our exponent is negative 2. That means this is a 2, this is a 2, and this becomes a 4. So this is a 4th, which makes this 5/4, which is, 5/4, which is 1 1/4, which means that point would be about there. So this would be 5/4, and if you notice the pattern, this would be 5/8, this would be 5/16, this would be 40, this would be 80, and that's because this number right here is the number 2. Wow, that's really thick, Mrs. Leonard. This number right here is the number 2, which means all of these things are doubling. If you take this times 2, you get 5/8. If you take this times 2, you get 5/4. If you take this times 2, you get 5/2. If you take this times 2, you get 5. Times 2, you get 10. Times 2, you get 20. Times 2, you get 40. Times 2, you get 80, etc., etc., etc. So basically, if you plot these points, this graph is going to get extremely close to that asymptote. But remember, it's not ever going to touch that asymptote. It's going to approach it, but not touch it. And then it's going to curve like this. I kind of missed points there, but you get the idea. Let's see if we can pull that a little bit. There we go. And put an arrowhead on that. So, things we know then. We know the domain goes as far to the left as possible and as far to the right as possible. We know the range. We actually knew the range as well. We weren't sure if it was going to open up or go down. So the range we now know will approach 0 and go up from there. We know the y-intercept. We found the y-intercept early on. The y-intercept was 0, 5. And we have different end behaviors. So the end behaviors. And you know what? We're going to do this like JCCC asked on the last test. So we're going to say the left-hand side is going towards 0, and the right-hand side is going up, and up is infinity. So the left hand is approaching 0, and the right hand is approaching infinity. In other words, the arrow on the left is getting very, very close to that horizontal asymptote. That horizontal asymptote is 0. And the arrowhead on the right is going up, which is going towards infinity. And I noticed on the test that was given the other day, that's what it looked like. All right, so let's look at the next one. So the next one, make these a little bit smaller. There you go. The next one, let's pull these notes so that they're easily accessible to us. All right, so the notes tell us that we have a number here of -2. So that means I'm going to have a horizontal asymptote at, whoops, what is that? Y equals -2. So I am going to have a horizontal asymptote that goes through -2, just like this, and that's going to be dotted because it really isn't part of the graph. Okay, so that's our horizontal asymptote. So now that I know that, let's let x be 0. I think I would like smaller. So let's do the problem letting x equal 0. So if we let x equal 0, that's 4 times 3 to the power of 0 minus 2. So if that's 0, that's 4 times 3 to the 0 is 1 minus 2. That is 4 minus 2, which is 2. So we have the point 0, 2. So we're going to plot 0, 2, and 0, 2 is right there. Okay, what if we let x equal 1? If we allow x to equal 1, that means the exponent is 1. 3 to the first power is 3. 4 times 3 is 12, and 12 minus 2 is 10. So I have the point 110. So here's the point 110. So I know the next one's going to be off my graph. So let's go the other way. Let's use x equals -1. So if we allow x to equal -1, if we allow x to be -1, that makes this 1/3. That makes this 4/3. And 4/3 minus 2. 4/3 minus 2 is 4/3 minus 6/3, which is negative 2/3, is negative 2/3. So negative 2/3. So the point -1, negative 2/3. -1, negative 2/3. So about there. Okay. And then let's let x be negative 2. We'll just do this one more time. See how horrible this is going to become. Let this be negative 2. Oops. Negative 2. Means the power is negative 2. That means this is 1/9. That means this is 4/9. So that would be 4/9 minus 18/9, which would be negative 14/9, which would be negative 1 5/9, so that would be like about there. And then these things are going to get closer and closer and closer without touching. So it's going to come in there like that. That's going towards infinity. This is going towards y equals negative 2. So our domain was negative infinity to infinity. Our range is negative 2, right? Yes, negative 2 to infinity. And our end behaviors, so the left-hand side is going towards negative 2, and our right-hand side is going up towards infinity. Oh, and by the way, the graph is increasing from negative infinity to infinity. And the same is true here. This one is increasing from negative infinity to infinity. Okay. So this one, I wonder what that dot is. Will that erase? Yep, good. All right. So let's see if we have the notes. Yep, there are the notes. Easily accessible. Have them really close. All right. So I am going to have a horizontal asymptote at positive 4. So my horizontal asymptote is going to be y equals 4. So I know that at the line, y equals 4. My graph is going to approach that line but never touch it. And that's why it's going to be dashed. All right. And let's write y equals 4 there. Okay, so what about when x is 0? So when x is 0, we're going to say f of 0 would be 3 half power 0 minus 5 plus 4. This is going to be ugly immediately. All right, so when x is 0, we have 3. We have a half. 0 minus 5 is negative 5 plus 4. We have 3. So 1/2 raised to the negative 5th is 2 raised to the 5th, which is 2, 4, 8, 16, 32. It's 32, so that's a 32. And this is a plus 4. So this isn't going to be something we can plot, because that would be 96 plus 4, so that would be 100. So the y-intercept is 100, which is not going to happen. Okay, so let's do this. What if we let f equal negative 5? So what if we let x equal negative 5? So you come in here. And we're going to say let x equal -5. Look, I don't even have -5 on the table. Let's put it on the table. -5. So, oh, let's not do -5. Let's do 5. Sorry, let's do 5. We don't have 5 on the table. Let's put 5 on the table. Let's let x equal 5. If x equals 5, then 5 minus 5 is 0. 1/2 to the 0 is 1. 3 times 1 is 3. And 3 plus 4 is 7. So when x is 5, y is 7. So 5, 7. Okay. Oh, my back is itching. 5, 7. So let's plot 5, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. That's going to be right here. 5. Okay, what if we let f be 4? So let's let f be 4. So we're going to come through here. We're going to let f be 4. 4 minus 5 is -1. 1/2 to the -1 is 2 to the first, which is 2. So that's 2. 3 times 2 is 6. And 6 plus 4 is 10. So when we used 4, we got 10. So let's plot 410. Well, 410 would be right there. Okay. What about 6? Let's do 6. I definitely needed a different table. Let's do 6. Let's let x equal 6. So when this is a 6, 6 minus 5 is 1. 1/2 to the 1 is 1/2. That's 3 halves plus 4. That's 5 1/2. So 6, 5 1/2. So 6, 4, 5 1/2. It's going to be right there. Okay, excellent. So if we continue on, what's going to happen is this graph is going to do this. And continue out this way. So it's going to look like, man, that's just not good, Mrs. Leonard. It's going to look like that. So that's the left-hand side is going to infinity. The right-hand side is going towards 4. Okay? So our domain is -infinity to infinity. Our range is 4 to infinity. Our left-hand side is going up, and our right-hand side is going towards 4. Yeah, I could have put different numbers in the box. Maybe I'll just leave them blank. It might be better. Okay. All right. So now let's do the next one. So this number is -1. So I know that I have a horizontal asymptote at x equals -1. So right here, I need to be thicker. So we're going to go to -1, which is right here. And we're going to dash it because it really isn't part of the graph. It is something we approach but don't touch. Okay. Then let's try 0 and see what happens when x is 0. Or maybe, you know what? Let's do -3. Let's do -3 first. And the reason I say -3 is we want our exponent to become 0. So let's do f of -3. So if we do f of -3, that is -2 to the quarter to the -3 plus 3 minus 1. So that would be equals negative 2. 1/4 to the 0 power minus 1. So that would be negative 3 equals, anything to the 0 power is 1. So that would be negative 3 is negative 2 minus 1. So when f is negative 3, y is also negative 3. So negative 3 yields negative 3. So let's plot negative 3, negative 3. 1, 2, 3, 1, 2, 3. There. There's our first point. All right, let's try negative 2 then, because I think that's going to be plottable. So when f is negative 2. So let's change this to letting x be negative 2. So when x is negative 2, negative 2 plus 3 is 1. 1/4 to the first power is 1/4. That is negative 2/4. Oh, that's a negative 1/2. So negative 1/2 and negative 1 is negative 1 1/2. So that would be right there. And then this is going to get progressively closer and closer and closer and closer and closer. So let's do, that was negative 2. Negative 2 got us negative 1 1/2. Let's do negative 4 to get another point going the other way. So let's do negative 4 and see what happens with the negative 4. All right, so if our power is negative 4, so if x is negative 4, negative 4 and 3 is negative 1. This is the number 4. This is the number 8. This is the number negative 9. So that would be down here. So this graph goes from way down low to here, and then curves and gets remarkably close to negative 1, but never touches it. So this gets very, very close to negative 1. Down here gets very, very close to negative infinity. So our domain, let's pull this and make this a little bit smaller, just because we've written all over everything. Our domain is negative infinity to infinity. Hope you're seeing a trend there. Our range this time is coming from negative infinity and not getting any larger and not touching negative 1. Yes. And our left-hand side, our left hand is going towards negative infinity, and our right hand is going towards negative 1. And the reason it's flipped over is because its leader was negative, and when we did translations, that flips them upside down. The plus 3 in the exponent moves it to the left to 3 places, and the minus 1 drops the graph 1 place. So it all works. You can obviously put these in the calculator. I saved that for last because I think the video will go away when I try to open the calculator, but we'll see. So we had 5, 2 to the x. So if we try it, I might lose the video. Canvas. And the first problem was, video's still running, that's good. I think they might have fixed whatever the glitch was that they had in January. So on the calculator, the very first problem we had y equals 5 parenthesis 2 parenthesis raised to the power of x. And if we graph it, there it is. And if we want to put in y equals 0 for the asymptote, there's the asymptote. So that should look like the first one. The one we just did, let's clear it. The one we just did was, Negative 2 1/4, x plus 3 minus 1 was negative 2, whoops, the negative didn't show up, negative 2 parentheses 1/4 raised to the x plus 3, right? And then minus 1. And so you graph that. That looks like it. If you want to put the asymptote in there, the asymptote was negative 1. Again, the negative didn't show up. It doesn't like. There we go. And there it is on that graph. So that's it. That's what it looked like. And you can obviously put them in Desmos. So if you put them in Desmos, you would go y equals negative, what was it, a negative 2 parentheses 1/4, close it. Here's what's interesting when you put it in Desmos. When you raise the power, you need to open a parenthesis and put in the x plus 3. If you don't put it in parentheses, it'll drop it down. And then go minus 1. And so there's the graph we just had in the last problem. And then if you want to see the asymptote, you can do that. Y equals negative 1. There's the asymptote. But if you spread this out, you see that the curve, which is red, never touches the asymptote. So see how it really never gets to negative 1 no matter how far down you go. It never gets to negative 1. It looks like it, but it never gets to negative 1. I can't get it back now. My fingers aren't working. All right, friends, that's how you do those. Have a great day.